Hello. Yes, I do come from Seville, but I don't have a classic Seville accent. I'm from England. I just live in Seville at the moment. So yes, just out of my own curiosity, who here is from Spain? Probably more than half of you. That's great. Awesome. Hello. I'm not going to speak in Spanish. I do apologize. I never do. So yes, I'm Trisha. I work for JetBrains. I work mostly for with IntelliJ IDEA, and my job is kind of to stay on top of Java technologies and figure out how they apply to us as Java developers in our day job, so that we can become more effective. So the goal of this talk is to give you an overview of what's coming in Java 9, because obviously that's the sort of big topic for this year. What we're going to look at is we're going to look at real-world Java 9. We're going to take a quick look at Jigsaw, because this is the sort of big topic for Java 9. We're going to take a look at reactive programming in Java 9, and then we're going to look at everything else, depending on how much time we have. So firstly, why Java 9? Apart from the fact that it's the newest, biggest, best thing, and we always want to stay up to date with the new stuff. We get free things straight away with Java 9, and one of the things that the Oracle guys in particular try to do with each new version of Java is make it better performance, make it just better for us to use without us even using the new features. So we get better use of memory, better performance, it uses new CPU instructions, and so forth. So generally speaking, even if you don't do anything using the Java 9 features, you should get some good stuff just by using Java 9. Of course, the thing you'll probably hear about is Jigsaw, sort of modularity for Java. That's like the big ticket item for Java 9, which is fascinating because I think as developers, we're probably not super excited about making our code modular. It doesn't really feel like it was worth waiting 7 years for, but don't tell Oracle I said that. The other thing that a lot of people will be talking about is the REPL. Who's heard of the REPL in Java? Only a few of you. Who's used a REPL in another language? A whole bunch of you. So Java's getting a REPL, which means that we can write stuff on the command line and try out small snippets of code, which is quite cool for Java, because previously you have to have a class with all the associated sort of paraphernalia, public static void main, and all of that kind of nonsense. And from Java 9, we'll be able to code stuff on the REPL and sort of try and work in a quick, iterative sort of way. Which I find kind of interesting, but not having worked on other languages, for me, I'm not really entirely sure how that will look for us as Java developers. We might get a chance to look at that in this talk. We probably won't. And then as developers, we don't really know anything else about what's coming in Java 9, because those are the two things that get told to us again and again. But it turns out there are 1 or 2 other features coming in Java 9. Just a few. A lot of these are sort of behind-the-scenes stuff. Some of them are very specific, like specific graphics improvements or specific improvements for certain platforms. There's a bunch of stuff done specifically for Windows and Linux and the Mac. There's a load of things that have been done behind the scenes in terms of unifying the logging behind the scenes, in terms of them writing performance tests and suites for testing the code. So some of those are not necessarily things that we will see as developers. So what I wanted to do is kind of pick out the interesting features that we might use as developers. First off, to set the expectations suitably low, some caveats and disclaimers. So don't use Java 9 in production yet. Please don't. It's not out yet. We are still at the early access release kind of phase. It's supposed to be coming out in July. We'll see. July seems awfully close right now, and I don't think Jigsaw's ready yet. So everything is early access. So you can download a version of Java 9 and use it, but things are still evolving even now. For example, in this talk, I'm using Java 9 early access build 166. The current release is build 169, which does not work with the current build of early access IntelliJ 2017.2, which has only just come out. So at the moment, things are still very, I won't use the word unstable, I'll say interesting. And you know, every time you download a new version of Java, something different breaks, which is really fun if your job is like my job and you have to download the latest version of Java and see what broke this time. I've raised a lot of bugs recently. So everything is early access. It is worth playing with. We are getting closer to the final version, but I'd like to say this now, so when something breaks in this talk, you don't blame me. Also, we don't really know what best practice looks like for Java 9. They haven't even finished writing it yet. So we don't know really how we're going to use it, what are the best things for us to do. We're really only just finding out what to do best practice-wise with Java 8 lambdas and streams. So I'm not really going to tell you this is the best way to use Java 9 when it's not even out yet. But we will take a look at things which might make our lives easier as developers. So the case study I'm going to look at is I'd really wanted to apply Java 9 to a sort of real application, hence real-world Java 9. And what I've got is I have a Twitter dashboard. It's a JavaFX dashboard which responds to a real-time stream of Twitter information. And this is an application I wrote to demonstrate Java 8 and lambdas and streams. So it uses Java 8 throughout the whole application. It's kind of split into very tiny services because apparently people are keen on micro-sized services. And they kind of all run independently. And this works quite well in terms of the Java 9 features because we can start looking at reactive programming, event-driven design, and we can also apply different things to these different independent services. If you're interested in the specifics of this application, then you can have a look at all the other talks I did on that application. I'm not going to go into it in any detail, but the point is, it is an application that does exist, and I did have to go through the pain of migrating it to Java 9, and that's really what we're going to look at. So let's take a quick look at that pain. Let's take a look at how painful it is to compile with Java 9. Because if you've heard anything about Java 9, you've probably heard that Jigsaw and some of the new features will potentially take away some of the features in Java that we've used in the past. And so let's take a look at how painful it is to start using it. Let's put my glasses on so I can see. So, I'm going to switch to a branch which has got the Java 8 version of this code and compile it in Java 9. Let's see what breaks. Well, at the moment, nothing's happening. But that's because the first time you build something, it always takes forever. That's what I'm saying. And it's not the fact that my computer has decided to just give up. You know when you demo something to your boss and he's like standing over your shoulder, or she is standing over your shoulder? This is like that, but with like 400 people in the room instead. What could possibly go wrong? I'm going to have a drink of water. It's thinking, there's a progress bar at the bottom. It's because I switched branches. What I did is I compiled an entirely different branch, which was totally happy, and then I switched into something which is not so happy. So let's put this into something so you can actually see it. Okay, so it's telling me a couple of things. One, as of release 9, underscore is a keyword and may not be used as an identifier. So in this class file here, I had underscore as a field name, which I didn't really use. I put that in there to show that it was an error. A lot of people don't realize that underscore was a perfectly valid field name, parameter name, variable name. And people were using it very rarely to do some sort of clever kinds of things and have very succinct and completely unreadable variable names. From Java 9, you will no longer be able to do this. And the reason is because in Java 10 or maybe some later version of Java, we'll be able to use underscores to do interesting stuff with lambda expressions, for example. So that's good. It'll be a reserved word. So the best thing to do is obviously rename this to something. I can still use underscore with something. I just can't use it on its own as a name, which is good because it was a terrible name. So if I then recompile it, I'm going to be flicking back and forth between the modes because of reasons which are too boring to go into. So let's recompile that. And then we'll see we have an error here. So cannot resolve symbol base 64 encoder. Now, this did compile under Java 8. It does not compile under Java 9. And this is the kind of famous encapsulate internal APIs thing, which could break all of our code. But it'll only break all of your code if you're using any sun.misc type packages, which you shouldn't have been using anyway. Now, I actually was genuinely using this in my Java 8 classes because I was too lazy to find out what the replacement was. And I knew it was the wrong thing to do, and you're not supposed to use it, but I did it anyway, which is what we do as developers. So what we want to do instead of using base64 encoder, is we use base64, java.util, and we can do get encoder, and we can say encode to string, and then everything compiles. So these internal APIs do have replacements. The ones that have been hidden away all have replacements in Java 8 and Java 9. You can actually check for these in your Java 8 code to see what's there and put the replacements in your Java 8 code without moving to Java 9 to begin with, and then everything should compile under Java 9. So that's all I needed to do, and then all my code compiles perfectly happily. So this was not the kind of like scary thing that I thought it would be, where you move it to Java 9 and everything breaks. There was just one or two things, and I knew what both of those things were anyway. I should never have been using sun.misc in the first place. So that was actually a lot less painful than I thought. So what we should do now is we'll take a look at the thing that I originally didn't want to do with Java 9, and we'll take a quick look at Jigsaw. Any minute now. So Jigsaw, modularity for Java. It doesn't sound, I hope no one from Oracle is here, it doesn't sound terribly exciting, to be honest. It's spent a lot of time, it's great for the JDK. What they've done is they've split the JDK up into individual modules. It's good design, it's a good thing to do. It allows them to hide away internal APIs like we've seen. It gives them much more control over their code. And it's a good thing, but from our point of view, if we were writing modular code, we were probably already using maybe Gradle or Maven to write modules, or maybe OSGI or something else. So having it as part of the language is not super exciting. But what I do want to do is I want to show you what it looks like if you start using it, because we might as well see how to use it as developers. Now what I had, you can't see the words and that's kind of fine, is I had a fairly standard Gradle structure to my application. So I have a few different modules already, and those modules all have a source directory inside it and a test directory inside it. And this is our standard Maven Gradle structure. Now, when I started looking at the Jigsaw documentation, it says that what I need is something slightly different. And what I need is to have a single source directory and a single test directory, and all of my modules inside that. And that's what the JDK does. So the JDK, this is the open JDK, and what it has is it has a source directory, all of the JDK modules, and then a test directory and all of the JDK tests. This is kind of inside out from a Gradle point of view. So it's kind of, in order to get my code into the Jigsaw way of doing stuff, I had to do quite a lot of moving everything. And I did that to sort of follow the best practice of Jigsaw and stuff and see what it looks like. Also, I did that because Gradle doesn't work under Java 9 right now. Gradle will work in version 4 point something down the line, but it doesn't work. So I ripped Gradle out anyway, so I thought, well, let's see what it looks like with a Jigsaw structure. Now, it turns out you don't need to do this, which is good, because who wants to rearrange their entire code structure just so they can use a different form of modularity, which, by the way, doesn't work with your build tool. So that's not really something we want to do. So what I wanted to sort of show is that this is the structure that you'll read in the Jigsaw documentation, but you don't need to do that. It will work with the Gradle and Maven way of doing stuff. It's totally fine. To turn my code into something modular that the JDK understands, and in this case that IntelliJ IDEA understands, is using Jigsaw as a modular module, JPMS module, I need a module.info Java file in each of my modules. It needs to be in my source folder. So yeah, in my source folder. And what I ended up doing in order to get everything working is I have that in my production code. I don't have it in my test code. And this is because JPMS modules don't like split packages. So if you have the same package name in two different folders, it says you can't do that. They need to be in the same folder. There is a fix, or there is a way of getting it to work for tests, because of course you're bound to want to do that with test code. But I chose not to do that because I was on a strict deadline in order to get the demo out. And I can get this to work inside the IDE. So what I've done is I've turned my production code into modular code, and I've kept my test code so that it runs from inside the IDE. Now, what I did as part of this exercise, of course, is I started thinking in terms of modules. I started thinking in terms of dependencies. I started looking at the sort of the structure of my application. And it turns out the structure of my application, which I did think about and I did design in some loose way, made no sense at all. It was just stupid. So I had two back-end services, and my back-end services were dependent upon the code of another back-end service. Now, the back-end services should be allowed to consume stuff from that other service, but they shouldn't be dependent upon code from that other service. It makes no sense to do that. They should be independent services. On top of that, my client code is dependent upon the WebSockets API. I use WebSockets under the covers, but none of my other modules depended on the WebSockets API, which again makes no sense to me, especially as all of the modules were dependent upon my reusable service module. So why am I dependent upon this extra thing as well? And then I'm using the Reactive Streams API, which we'll talk about a bit later on, and that's being used by two different services, and it's not really clear as to why it's used by those two and not the others. After looking at all of that stuff, I rearranged my whole modular structure, looked at my dependencies much more closely, decided what should really be dependent upon something else, and it turns out that all of my services are all now at the same sort of level. They don't really depend upon each other, they're all independent, so that's a good thing. They all depend upon my reusable service code, which is what that service code is for. It's supposed to be reused between all of my independent services. And that's great. And that's the only code which cares about WebSockets, because that's the only code that knows about the implementation under the covers. And then my back-end services are the only ones that care about the Reactive API. And that's hidden away from them, the implementation, again, by my own wrapper class for reasons that we'll get onto a bit later on. I have two back-end services that are dependent upon RxJava, and a different service which is dependent upon Reactor, because what I want to show is that by using the Reactive Streams API, I can use different implementations under the cover, and that's completely fine. So thinking about modules had me thinking about the design and structure of my application, and I ended up with a much cleaner design, so this was definitely a good thing. Let's take a look at actually using the Java platform module system and what it looks like to implement. So what I've got is, these are my modules. Why can't I make that bigger? All of my other modules have a module info file to say, this is a Java module. I have this module here, my flow module, which doesn't have a module info file. So we'll create one and we'll see what that looks like. We'll see what we have to do in order to get that working. So in IntelliJ, I can just use a cheat. I can have it create a module info for me. It takes a guess as to the module name. In this case, it's using the IntelliJ module name for the Java platform module system module name, the Jigsaw module name. So that's fine. And then as soon as I've done that, all I've done is created a module info. When I recompile, then what happens? Definitely getting the sensation I should have rebooted my computer before I did this. Hello. Okay, so now I'm starting to get some errors. The module flow does not have the module java.logging in requirements. Now this might seem kind of weird, because this, java.util.logging, is part of the JDK. This is part of the Java platform. And it's basically telling me, oh, I don't really know anything about this class. And so what you have to do now you've said I'm using modules, you need to declare which of the JDK modules you're using. So I'll just get IntelliJ to fix this for me, because I'm lazy like that. If I go back to my module info, then what it's done is it's added requires java.logging there. So the JDK, as I showed you in one of the earlier pictures, the JDK is now broken up into a bunch of different modules. For example, Java, oops. So now we have all these different modules as part of the JDK. What it means, this is a good thing, this means that you no longer have to actually use any of the stuff that you didn't use, like Corba, for example, or RMI, or SQL. If you're not using SQL, you don't need to rely on SQL. This allows us to use a much smaller footprint of the JDK if we want to. But if you are using any of those, you now need to explicitly declare them. The only one that you get for free is that you get java.base. And that has a lot of the java.util stuff, so all the collections and things like that. So all of that stuff comes for free. You don't need to import that. That's just naturally part of your application. So now that we've done that, what else is going to break now? Well, it says I can't find subscriber. That's because I need to add the Reactive Streams API to my class path. So because I'm not using Gradle, because it doesn't work, I'm using IntelliJ IDEA to manage my dependencies. So that's just going to be, I'm going to add that to my class path in IntelliJ IDEA, and then I'll get a different error saying that the module flow does not have the module Reactive Streams. Now the Reactive Streams module is from an external jar file. This is not part of the JDK. So I'll get IntelliJ to fix this for me. And what it does is it figures out that I need to say requires Reactive Streams, and this is a magic name which is created from the name of the jar file. And this is automatic modules. So you can go away and have a look about what automatic modules are, but the point is that you don't need to be using shiny new modularized code. You can use old jar files that don't use Java 9 modules, and you can import them as if they were modules. And it'll do that by basically using the jar file name. So the jar file name in this case is reactive-streams with a version number, and that gets turned into reactive.streams as a module name. But basically what I'm going to use to get this working is I get IntelliJ to tell me what I need to do in order to fix everything. So there's one more error which will be happening now. Now I've created module info. That's fine. I've created this flow module under Jigsaw. And what I should find is, when my error comes back up, okay, so I have this class in a different module. So this is my user module, and it's using something from my flow module. And now it says the module flow does not export the package. So what I need to do is, in my flow module that I just created, if I want to use anything from the flow module, what I need to do is tell it which packages I'm exporting. And now other modules that depend upon this flow module can see anything inside the flow package. Of course, the whole point here about hiding away internal APIs is if I had other packages which had implementation details, I don't export them, don't let other people see them. Okay, so that's all I need to do to kind of get this stuff working. So Jigsaw is like, it was a big process for the JDK to modularize all the code, but in order to actually use it, provided your code is already kind of modularized, it's not that tricky, and there are tools that can help you. So the IDE can help you, the compiler can help you. There's also a tool called JDEPs, which will help you to identify which jar files and which modules you're dependent upon, and you can use that to create your module info. For example, these module infos start to get a little bit more tricky. Let's have a look at my UI one. The compiler is really useful. The compiler will tell you things like, you need the JavaFX modules, and then you just add them, and that's fine. So this stuff is actually fairly easy. It will also tell you, so JavaFX uses reflection. So in order to allow JavaFX to reflect over my code, I have to say that I open specific packages to JavaFX. And then only anything inside JavaFX can use reflection over my code. Nothing else can use reflection over my code. This is the point about the modular system. It's to allow things to be much safer. It's allow you to specify who can do what to your code. So that's kind of fine from that point of view. And then some of the modules get a little bit more complicated when we start looking at things which rely on external dependencies. So what I did is I used brute force trial and error in order to come up with this module info file, which was extremely painful. It turns out there's a tool called JDEPs which does that for you. I highly recommend, if you were going to do this, read the documentation of JDEPs and figure out how to use it. It's not super easy to figure out how to use it, but it's much easier than doing this kind of brute force trial and error. Oh, what's missing now? Because some of these dependencies are runtime dependencies. And then you just get like a class not found type exception, and that's really not useful at all. Okay, so that's Jigsaw, which I said I didn't really want to talk about, and then I end up spending, as usual, about 20 minutes talking about it. Let's talk about The pain. So the pain of moving to Java 9. My biggest pain was the fact that Gradle doesn't work. So that's quite a big pain, because I can't run it from the command line. I can't run the build inside the IDE, because the IDE uses Gradle too. So the fact that Gradle doesn't work with Java 9 right now is a pain. Maven does work. Ant does work. The IDE works if you don't have a build tool. Gradle does not currently work. You can use a magic incantation, which involves not running the daemon, you have to open up packages from the JDK, and there are some command line switches you can use in order to run it from the command line only, but it's a bit of a pain. They will fix it. They are aware of it. They are working on it. If you follow the Jigsaw best practices, reorganizing the file structure of your application is non-trivial and probably not something you want to do. But it turns out you don't have to do that. You can use a standard Maven or Gradle file structure to get it to work. This project has no command line build because Gradle doesn't work. So it's not really something I can run in continuous integration. I also did some research this week. It turns out a lot of the CI servers don't currently support Java 9 fully. So some of them, if you're using something like Maven, will work. Some of them will not work, especially if it's using the same Java home as to build the CI server as it is to build your application. So not all the CI servers play nicely with Java 9 yet. The IDE support is not fully there yet. You saw that IntelliJ IDEA does support things like code completion and some quick fixes, but not everything is automatically quickly fixed for you. What I would love to see is I'd love to see a generate my module info for me feature, which I'm sure will be coming at some point. But right now, everything is kind of trial and error, and a lot of the documentation you'll see is from the command line, which I'm not used to working from the command line. I use an IDE because I work for a company that creates an IDE. And do some reading. Do read about JDEPs specifically, because JDEPs will make your life a lot easier. Again, that's all command line type stuff, so it's a bit awkward if you're not used to working that way. Right, let's talk a little bit about the Reactive API, because Reactive is coming to Java 9. This either means that Reactive is like, it has won, it is the way to do stuff now, or it means that Reactive is the new deprecated. I'm not really sure. If it's part of Java, then maybe no one cares about it anymore. Reactive is good, by the way. You should use reactive programming. It's a really good way of doing asynchronous programming. Who knows about reactive programming? A bunch of you. Is anyone using it in their applications? Probably about less than half of that. I'm not going to talk in depth about reactive programming. It's an asynchronous, event-driven type way of doing stuff. I will kind of show you the context of using it, so that might give you a sort of bluffer's guide to some reactive programming if that's interesting to you. There's a Reactive Streams API, Reactive Streams 1.0, which a lot of the, so in order to be a reactive library, a lot of the JVM reactive libraries implement this. The sort of basics of being reactive is that you have publishers and subscribers. And you also might, in our case, we have a processor, which is a combination of a publisher and a subscriber. And we have a subscription, which allows things to manage how the subscriber talks to the publisher, or the other way around, really. Implementations of the Reactive Streams API include Akka Streams, Reactor, RxJava, Vertex. So a lot of the reactive implementations that you've heard of, they all implement the same API. What's happening with Java 9 is that API is going into Java the language. This will be part of Java the language, so you don't need to use the Reactive Streams API as a separate jar file or just as part of your part of the library that you're using. It will be part of the language, so anything which kind of runs on the JVM will be using the language version of the API, except that the language version of the API is not exactly the same as the API that's currently out there. It looks exactly the same in terms of the interfaces are the same, the names of the interfaces, the method signatures, but the package structure is completely different. So if you're using RxJava at the moment, then you're using the org.reactive streams API, not the Flow Java 9 API. So for this reason, for this particular demo, I created that Flow module, which is my adapter. So it adapts between the Reactive Streams API and the Java 9 API, and vice versa. There are some things coming into Java 9 which might make their lives easier in terms of doing this, in terms of moving towards the new Java 9 API. But it's worth being aware of. Yes, and RxJava talks specifically about they will be using the Java 9 Reactive API when they can. So where would we use a Reactive API? In my application, I have really stupid services. My services they use WebSockets. I have one input, one output. And what I do is I have the business logic in the middle. This is basically every architecture diagram ever. Input, output, stuff happens in the middle. And because this was meant to demonstrate Java 8 features, what my business logic is, because my services are really tiny and very stupid, my services basically have a lambda expression as the business logic. And this is more or less a mapper. I have strings coming in one end, I map it to some other string, and then I have a string output. So that's what my services look like at the moment. What I can do, especially to give it a bit more power, is I can think of the sort of input end of my service as being a publisher. So it publishes strings. My business logic is going to do some sort of processing on this, so it's going to listen to this publisher, do some sort of processing, some set of operations on it, and then something will subscribe to my business logic to do something with the output. And that subscriber in this particular case is going to put stuff on the WebSockets for anyone else who cares about the output of this service. So in my application, my publisher is a class called client endpoint, because it deals with WebSocket endpoints, and my subscriber is a class called broadcasting server endpoint. So let's take a quick look at those. Let's switch branches. So my client endpoint implements flow.publisher. Stay still. So that's what makes it use or expose the Reactive API. So my client endpoint, I migrated it so that it now implements flow publisher so that I can be more reactive, because reactive. And what publisher is publisher just has a subscribe method on it, which takes a subscriber. So what I've done, and I don't necessarily recommend you do this, is that I have implemented my own version of this. So my client endpoint, because I already had something similar architecturally, I was already sort of dealing with events and messages anyway, and I already had things listening to this endpoint. So what I've done is I've basically implemented my own version of the publisher. And so this is my subscribe method, it takes a subscriber, and then I have to sort of manage what I do with those subscribers and their subscriptions. And what I do is I just kind of keep track of those subscriptions, and then every time I get something on my on the WebSocket, I tell the subscriptions or the subscribers that use the subscriptions, I tell it about that message. So that's quite simple. It's not that difficult, which is why I implemented my own version. Let's look at the subscriber side. So my broadcasting server endpoint implements flow.subscriber. Flow.subscriber is a little bit more complicated. This has an on-subscribe, an on-next, an on-error, and an on-complete. And these are the things I need to implement. And these are kind of fairly straightforward. On subscribe, I'm just going to request everything from the business logic and just give it to me forever, because that's my job. On next, I'm just going, that's every time I get a message, what do I do? Well, the job of this thing is to put it on the WebSockets to anything who's listening. On complete, close everything off. On error. Never, ever, ever do this, particularly in reactive systems, ever. Reactive asynchronous systems, errors are very interesting, and they happen in entirely different places to where you expect. The stack traces aren't the way that you expect them to be, and so if you swallow errors, stuff will just stop working and you will have no idea what happened. So you really do need to think very carefully about error handling and back pressure when you're talking about reactive systems, and we will look at that a bit later on as well. So anyway, so this is me, this is how I'm going to expose my Reactive API. What we really are interested in, though, is what does this give us? Why do we really care about this? So I'm going to start using the reactive stuff inside my services to see what it gives us. I've got like 15 minutes left, right? Oh, that's hilarious. Well, let's do this really quickly. And I said I wasn't going to speak really fast, because it's not fair on people who don't speak as fast as me. So I have this canned tweet service. What this does is I have a kind of service at the back end. I didn't really trust connecting to Twitter for demos. So what I have is I have a service which reads a file of tweets and then publishes stuff that looks like tweets so that I can sort of have real-time tweet data. So this looks really nice in Java 8. You can do files.lines, and then you get a stream of these lines, a stream of strings. And then I just basically publish it to anyone who cares. That's quite nice. It's a really nice way to demo Java 8 streams. We can do this with reactive streams as well. So I'm using Rx Java. So I have what do I have? A flowable? I don't remember. I only did this last week, and now I can't remember anything. My question is, am I using the right thing? Hold on a second while I try and remember what it was I was doing here. Live coding, what could possibly go wrong? Can tweet service. It is a flowable, I just can't find it. I just need to add Rx Java to my path. Normally IntelliJ does all of this for me, so I don't have to think at all. That's kind of the nice thing. Rx Java, fine. Let's have that. Let's do that. Now you can find it. Excellent. And then I have to add it to module info because we're in the Java 9 world now. So I say flowable from iterable. I can't use the nice files.lines thing with the try with resources because I'm not using the Java 8 stuff, but I can do something fairly similar. I can say I want to read all the lines from the file, give it the path. And then what I do is I basically do exactly the same thing I was doing before in Rx Java. There's one subtlety. There's no such thing as peek. Peek in Java 8 allows you to do the same thing, so like an operation on every single item that comes through through the stream. And what I can do is instead in Rx Java, I just say do on next. So that looks almost exactly the same as my Java 8 version of this. What I've done is I'm now doing exactly the same things I was doing before, except I have another external dependency, and it's not quite as pretty as it was before. So, arguable about the benefits of doing this. But what you can do is Rx Java and Reactive Streams work in a different way to Java 8 Streams. Java 8 Streams are basically a nice way to query collections. And you can query collections over multiple CPUs if you want to. But that's a different thing to Reactive Streams. Reactive Streams are meant to be like an infinite stream of events. And you can do things like you can have multiple streams and merge them together, or you can have an individual stream and split it. And these streams can have multiple consumers and do different stuff with them. Whereas Java 8 Streams, you can do like one thing with it and one thing only. So what we can do here, I was always kind of a little bit uncomfortable with this do on next. What I'm doing for the purposes of the demo is I'm inserting a 100 millisecond pause. And that's kind of part of my business logic, if you like, because for demo purposes, I need it to not be insanely fast on the UI. So it's kind of part of what I'm supposed to be doing. But it always felt like a little bit of a hack. Well, it works. But what I can do with Reactive Streams is I can do something a little bit different. So finally, it gets up and running, and you can see this is working. It's doing what it was supposed to do. Now, I can create a different stream in Rx Java. I can say flowable. This is killing me, the lack of speed here. Because normally IntelliJ does my typing for me. I don't have to type anything. Interval. And I'm going to give it 100 milliseconds. Oh. This is killing me. Start again. Okay, so what I've done is I've created another stream, and what it does is it ticks every 100 milliseconds and emits a long value. Okay, so the job is just to kind of tick every 100 milliseconds. And what I can do here is I can zip together my stream of strings, which comes from the files, and I can zip it with the tick. What I need to do is I need to say that given that, hello, I'm going to have to do this like, why don't I stop that? Given I have two streams and one of them is giving out strings and one of them is giving out long values, what do I want to do with those two values? So I can, I have a string value and a long value. Honestly, thank you. Not null by function. Right, I've got long value and a string value. What do I want to do? Well, I don't care about the long value. All that's doing is ticking for me. So I'm going to emit just the string of the tweet. So now what I've done is I've zipped together two streams to give me the ability to read the files and emit those strings at a steady pace. So that's kind of cool. That's something you can do with reactive streams that you can't do with Java 8 streams. I have another example of reactive streams, but I really want to get onto the other features inside Java 9. The point here was that inside the mood service, again, my reactive streams implementation looks a lot like my Java 8 implementation. In this case, I use Reactor, not RxJava, because the point is that you can use this Reactive API to talk the same language between the different services, but you don't care about the implementation under the covers. So I'm using Reactor. The implementation looks almost exactly the same as the Java 8 implementation, except that it doesn't work, and you can't really tell why it doesn't work. And it's because the concurrency model for reactive streams is really different to the way that Java 8 streams works. And you need to understand that. And you need to understand that reactive streams care about back pressure. So if the publisher is publishing faster than the subscriber can read that stuff, then you have to do something. You either need to drop stuff, or you need to, I don't know, fork the process or do something different. You have to understand what to do, otherwise the whole thing just grinds to a halt. Right, so, yeah. 5 minutes to go through everything else in Java 9. Easy. No problem. Forget about the mood service. So yes, Java 8 streams look the same as reactive streams, but they're not the same. You have to understand that there's a totally different model behind the scenes there. Other Java 9 features. Convenience factory methods for collections. This kind of looks like the stupidest thing, and I think this will be the most used, most useful feature inside Java 9. So for example, in the olden days, now, what we had to do in order to create lists, for example, is we say arrays.asList, and that gives us a list. That's great. In Java 9, we can say list.of instead. Yay! We just saved ourselves I don't know, 4 characters or something. This will give us an unmodifiable list. That's great. But what's much more interesting is you can do the same thing with sets. Okay, I said sets with a T, for anyone who's not listening in English. Instead of having to do this, which is what we used to have to do, have a list and then put it into a set, and then if you want to make this an unmodifiable set, then you have to wrap that inside an unmodifiable set, and it gets pretty ugly pretty quickly. And what we can do in Java 9 is we just say set of. Ta-da! So that's really nice. It's just going to reduce a lot of the boilerplate. We can do the same thing with maps. So, mood analyzer. If you want to initialize a map with just some set of standard values right at the beginning, so in this particular case, I wanted to map words to a mood which might relate to that mood, you have to do this. You have to have a static block, and it's kind of ugly. And what you can do now is you say map.of entries, of entries, and then you give it a bunch of entries. So I can say Okay? That's not going to compile because I can't bother to do everything because we don't have loads of time. But you basically give it a set of entries with the key value pairs. If you have less than 10 of that, you can do something even easier. So you can just get rid of all of that. You can get rid of the of entries stuff, and you can say map of, and you just give it key value, key value, key value. So it's going to be much easier for us to create maps. When I worked at MongoDB, most of my code was creating maps. So this is like super useful for me. We started using Groovy for testing because it was just much easier for creating maps in Groovy. It was much prettier. And this isn't quite as pretty as the Groovy way of doing stuff, but it is a lot prettier than what we had before. So I think these collections convenience methods are going to be really, really useful for us. What else? We also have... any minute now. Private methods on interfaces. This sounds really stupid because interfaces are supposed to be your public API. But in fact, now Java 8 gave us static methods and default methods. We have behavior on our interfaces. And what we can't do is we can't share anything between those different methods because we can't encapsulate stuff in a private method in Java 8. Now, if you've got two methods which look kind of fairly similar and they share a bunch of code, you can create that inside a private method inside your interface. So it's really useful if you are using default or static methods on your interfaces. There's new methods on the Streams API, which allows you to stop infinite streams, which you couldn't do before and was insanely frustrating. So you can say things like take while, so take like all the members of this stream until some condition is met, and then that will finish, and it's really useful. Or you could say drop while, so ignore everything up until some condition is true. These are really useful. The stack walking API, this I think will be really useful for error handling, like particularly maybe like reactive streams, and it allows you to lazily evaluate your stack trace effectively. So instead of having to sort of get the stack trace, which is a really expensive operation, we can kind of pass around queries and figure out like how many elements in our stack trace have our package name, for example. We can do some interesting queries on our current stack. MultiRelease jar files, also really interesting. A library developer can create a single jar file, and it will encapsulate Java 9 functionality separate from pre-Java 9 functionality. So I, as a library developer, can use Java 9 functionality if you're using Java 9 when you use my library. Otherwise, I use different functionality. So it will only work for Java 9 and onwards, so I can't create a multi-release jar file with a 6, a 7, and an 8 version, which is kind of sad. But it means that, for example, RxJava could give you a single jar file which exposes the Java 9 Flow API, or if you're not using Java 9, it will use the Reactive Streams API. This, I think, is really interesting for library developers. And for you, potentially easier. You don't have to say, oh, which version do I need to download if I'm on Java 6, for example. Process API updates allows you to get the PID of your current process, which is super useful. And then you can kill your own process, which is nice. Updated deprecation. This is really, again, silly, but really nice. So what it will do is if something is deprecated, it will now be able to tell you whether it's deprecated and will be removed, so stop using it right now, or deprecated, there's a better way of doing it. So there's a for removal flag on deprecation. It will also tell you when it was deprecated. So if it's deprecated like last version, then you've probably got a couple of versions before it dies, for example. HTML5 Javadoc, if you happen to be generating Javadoc, you can generate it in HTML5. That's good, I guess. I don't know. Who generates Javadoc? Javadoc Search. Last time I gave this presentation, someone thought I was being sneery about this. But Javadoc now, thanks to HTML5, has a search bar. And when you type in it, it actually suggests things to you. It's brilliant. I'm not being sarcastic. It's absolutely brilliant. And I can't believe we didn't get it sooner. It's just going to make life a lot easier when you're trying to find anything in Javadoc. JShell, we don't have any time to talk about JShell or the REPL. I don't know why I put this in there because I never have time for it. There is a really good tutorial on it. I think it's a little bit outdated, but it still gives you a good idea of the features that are available. These slides will be available so you can have a look at all the links. IntelliJ does not currently support an embedded REPL, but we would really like to do that. So if you have used a REPL in the past and or want to use the Java REPL inside IntelliJ, please tell us what your use cases look like because we need to understand what you want to do with it. Right, in summary, I'm so sorry. In summary, Yes, your code might break in Java 9. It is possible. The best thing to do is download Java 9 right now, see what's going to break, see what the pain is. If you're using Gradle, perhaps don't bother because it's just not going to work. But yes, try out Java 9 right now, find out what the pain points are. So, a lot of things are going away. Deprecated stuff is being removed. The applet API is being deprecated. I didn't even know anyone was still doing that. So there's a lot of things being deprecated and removed. There's also some interesting things where the behavior has changed, behavior that you probably shouldn't have been dependent upon in the past, but you might be. So for example, they've done a lot of work on logging. So if you were doing anything like parsing log messages to find out what was going on, those log messages might not be there anymore. The other thing which I think is really interesting is there's a new version string scheme. Java 9 is Java 9. It is not Java 1.9. So Java 8 was 1.8. Some of the things that you'll find failing, like CI servers and so forth, and other external tools, will be because they don't recognize the string 9 instead of the string 1.8. So this version string changing has a weird impact across the board. So Java 9 is still evolving. IntelliJ and the other tools that we're using are still evolving as well. Now is quite a good time to give feedback to those tools like Gradle, like Maven, like IntelliJ, like the JDK developers, so that they can figure out what the pain points are sort of before Java 9 goes live. You don't have to modularize your code. I know Jigsaw is like the big ticket item for Java 9. You don't have to make your code modular in order to use Java 9. And it's quite painful, so don't do it if you don't have to. And Reactive Streams are not the same as Java 8 streams. They've got different use cases. They don't do the same thing. So don't expect them to be the same thing. The gain. Java 9 does encourage good design. Modularization does make you stop and think about your dependencies, your structure, what code should really be dependent upon other code, how to encapsulate stuff. It is a good thing. It encourages new ways of working, like the REPL, like reactive programming. But I think the most interesting thing for me as a developer is you've just got some nicer ways to write code. So the collections helpers and the new process API, the stack walking API, these little things, these are the things which will make our job a little bit easier. All of the code, all of the links to everything about Java 9, everything is available on this link here, all the slides, everything. So go to there and download it. Thank you very much.